As promised, in this lesson, we'll talk about redistribution. We need redistribution in cases where we have two or more different routing protocols. In this case, we will do it between RIP and OSPF. So on the left part of this network, we will configure RIP, and on the right part of this network, we will configure OSPF. And then on this router in between, I'm going to redistribute the routes from RIP into OSPF and the routes from OSPF into RIP. So basically, what redistribution does is it translates the routes of one routing protocol into practically the language of the other routing protocol and vice versa. Let's start from this network on the left where we will configure RIP, and I'm going to start from router 0 and start advertising the networks that belong to RIP and are directly connected to router 0. So I'm going to say enable configure terminal router RIP version 2 no auto summary, and then advertise networks 11.0.0.0 and 11.0.4.0. Whoops, that's this network over here. I just made a mistake there, so that's it. Moving on to router 11, enable configure terminal router RIP version 2 no auto summary, and then advertising networks 11.0.0.0 and 11.0.1.0. That's right. On router 12, I'm going to advertise networks 11.0.1.0 and 11.0.2.0. On router 13, enable configure terminal router RIP version 2 no auto summary, network 11.0.2.0 and then 11.0.3.0. See, I made this networking part quite easy. So the addresses are very simple. I hope you'll agree with that. On router 14, we're going to say router RIP version 2 no auto summary, and then network 11.0.3.0 and 11.0.4.0. And that's it for RIP. Moving on to OSPF, I'm going to start from router 0 again. Let's create the OSPF process. It's going to be router OSPF 1. And then advertising the two networks on the right, it's going to be 21.0.0.0. Remember, in OSPF, we have to use wildcard masks and also define the area. In this case, we'll only have one area, so it's going to be area 0 by default, since area 0 has to exist in an OSPF network. So it's 21.0.0.0 and then 21.0.4.0 with the same mask in the same area. Moving on to router 21, enable configure terminal router OSPF 1, advertising 21.0.0.0.0.0.255 area 0, and then also 21.0.1, and that's that for router 21. On router 22, enable configure terminal router OSPF 1, advertising networks 21.0.1.0.0.0.255 area 0. Not fast enough. Okay, 21.0.2.0, and that's that for router 22. On router 23, enable configure terminal router OSPF 1, network 21.0.2.0.0.0.255 area 0, and then 21.0.3.0. I was faster than OSPF this time, but I'm not getting the neighborship message, so what's up with that? Okay, it's there, a bit late. On router 24, enable configure terminal router OSPF 1 network 2103.0.0.0.255 area 0, and then similarly for 2104. There we go. Okay. Now we want to redistribute, but before we do that, let's check what's going on with our routing tables. On router 12, I'm going to say do show IP route. And we can see here that we can only see the RIP networks, so the 11.0 something networks. Of course, we can't see the OSPF networks because these two groups of routers don't speak the same language, so they can't talk to each other. Do show IP route. On this side, we can only see the OSPF routes, so no surprise there. Let's do the redistribute magic. It's going to be done on router 0, where we have both of the routing protocols configured. So let's start from router OSPF 1. In here, we're going to redistribute the RIP networks into OSPF. Command is redistribute RIP subnets. This word subnets is to make sure that the classless RIP subnets get redistributed correctly. So we're telling OSPF don't fit those RIP subnets into classes A, B, and C regarding masks. Okay, that's it for redistributing RIP subnets into OSPF. In order to do the opposite thing, we need to get into RIP config mode, so router RIP. The command there is redistribute OSPF, and then you list the OSPF process ID, and then you say metric, and then so the reason why we use this keyword metric is because OSPF and RIP don't use the same metric. Okay, so the metric that RIP uses is the number of hops. And in here we have different hops for different subnets. So we're just going to say 1. We're going to say to reach any of these subnets, you need 1 hop. Redistribution is really not perfect. So ideally you would have 1 routing protocol inside 1 autonomous system, but usually that's not the case. So redistribution is kind of the last thing you want to do. It's used, I mean, it's not that wildly used, but it's used. But you should try, if you're designing a network from the beginning, you should design it so that you use 1 routing protocol in the entire network. Okay, let's see if redistribution worked. I'm going to go to router 12 and remind ourselves of what was the routing table prior to issuing these redistribute commands. And I'm going to issue the very same command again. And here we can see that we have learned through RIP all of these other networks. Let's go to router 22. Issue the very same command, and we can see here that we have learned these networks via OSPF. Let's try the ping just in case to see if everything's working, and it is. So that's how you redistribute routes between RIP and OSPF. In the next lesson, we'll do OSPF and EIGRP. See you there.